Hello.
Okay, welcome Autumn and Kate and Brittany and Booja and David and Jeremy and Jeremiah and Savannah and Cowdon.
Thank you.
For showing up. This is week 2 webinar. This is a week 2 webinar for the online statistics class. And the plan today, it's kind of a two-piece plan. First, what we're going to be doing is probability. Probability is important, and it's a big component of this class. But I do want to give you a warning, and I don't want to scare you too much, but I do want to give you a reality check, is that most students in the stats class consider chapter 3 to be the most difficult chapter of the entire class. So expect to be a little confused sometimes, maybe not, but most people have some issues with a few things. I'll do my best. The problem with it is it's really easy to watch me do the calculations and the stats and the probability actually. On the other hand, then you have to do it without me or with it just by yourself, and all of a sudden it's hard. So you'll probably look at it and say, that doesn't look too bad, and then you'll have to do your own, and it's a lot harder, as you'll see. So we will do some probability. I'll do lots of examples. In fact, I have one in particular that I do every quarter, and hasn't been successful yet, but hopefully this time it'll be successful. We'll find out the probability that it will be successful, as we'll see in a minute. And then after that, what we'll do is we'll talk about project 1. Project 1 is a very big component of this class. So it's something you don't want to take lightly. You need to make sure you work hard on it, follow all the different pieces that I tell you to follow, work well with your partners, and come up with a great project. So hopefully it'll go well for y'all. And I want to remind you, I'm here to help. And please post if it's a project question in the project discussion board, and if it's a general question in the Q&A discussion board. So let me ask you, are there any questions that you might have about anything before I move on? Any questions? Okay, and if there's no questions, what we'll do is we'll do some probability questions. So let me start out, and I think maybe I'll start out a little bit here, and then we'll move on to more complex stuff. Let's look at, let me see who we've got here. See if we can make this work. Yeah. Okay, so I'm going to let A be the event that the person's login name, so login ends in a vowel. And vowels, by the way, I'm going to let it be, just to make it easy, A, E, I, O, U. So that's what a vowel is. And so I'm typing this in chat box, but I'm saying it also. So if you can't see the chat box, so A is the event that the person's login ends in a vowel. And B is the event that the person's login has a repeated letter, has at least a repeated letter. Okay, does everyone understand what that means? So for example, my login ends in N, green, and I have repeated letters. In fact, I have more than one. I have RR and EE. Any questions? And repeated means in next to each other. So for example, Jeremy is not repeated because there are two E's, but they're not next to each other. All right, so what I want to do is I want to talk about a little probability. And I like to use y'all because I think it's easy, and I'll use myself too, so I'm in there too. So the first question is, find the probability of A. So let's find the probability that A occurs. Okay, A is the event that the person's login ends in a vowel. Okay, and I'm just looking at the names that are on the screen, and hopefully you have all the names also. So the definition of probability is the number that make it true divided by all the total possibilities. So if we want the probability of A, the first thing I'm going to write P parentheses A, then what I'm going to do is I'm going to count. I'm going to count the number of logins that end in a vowel. And let's see if you can tell me how many end in a vowel. You should be able to look at the list also. There's 10 people on the login list. And how many ended in a vowel? Okay. So let's see if y'all agree. So Jeremiah says 2. And notice we have Kate and we have Pooja. And the two of their logins end in a vowel. Any questions on that? And how many total are there? 10. So what we can say is that the probability of A is equal to 2 over 10. Any questions on kind of the basic definition of probability? Any questions on that? I also want to mention, by the way, that there are a few ways of thinking about this in terms of the probabilities. And again, Brittany's asking, should we reduce? Okay, or maybe we should write as a decimal. So I like this example because you could do anything. And it depends what you want it to say. If you wanted to tell the story, then 2 over 10 is better. Because then you could see there were 2 people that ended a vowel out of 10 total people. If you want it to be a prettier fraction, then you write 1 over 5. If you want it to be easier to do computations with, you probably want to write 0.2. Does that make sense for your questions, Brittany and Jeremy? So on the homework, read what it asks for. If it asks for reduced, then you need to reduce. If it asks for a decimal, you need to write a decimal. If I give it to you on the midterm exam, then I want you to show work and I'm happy. Okay? Justify where it's coming from. I'm good no matter what you write as long as it's the right answer. Any questions on that? Computers are pickier than people typically, so I'm less picky than a computer is. Any questions at all on this idea? Any questions? Okay, so now let's do some more. Okay, we also noticed there was event A, the person's login ends in a vowel, and event B, the event the person's login has at least a repeated letter. So find the probability. That if we pick a person from the list at random, then the person login will have a repeated letter and end in a vowel. Any questions on the question? So we want to find the probability of A and B. Now what and means is they both have to be true for this to happen. So in this case, how many people have a login that ends in a vowel and a repeated letter? Yeah, 1. That'd be Pooja. Thank you, Pooja. Good. I'm glad you got it because you are the one. So in particular, we can say the probability, I'm going to write P parentheses A, and then and B is equal to 1 over 10. Because there is one person who satisfies the requirements, both because it's an and statement, and there are 10 people to look at. Any questions on that? All right, now for the next question. We have a lot of questions with this kind of stuff. If a person is selected at random from the list. Okay, it's tricky. Shane, pronouncing is always hard by reading, but sorry if I pronounced it wrong, but no, she just walked in and that, or logged in. That's important, actually. That changes everything. Person is selected at random from the list. Find the probability. That person has ends in a vowel or has a double letter. Any questions on the question? Okay, what's the big difference between this question and the last one? And the hint is one word. Yeah, or. And or is really important. So when it's an or, that means either can happen, and if both happens, that counts too. So we're also going to do a count, and we're going to say how many people either end in a vowel or have a double letter. Okay? So again, you can just look through the list. Notice, and by the way, Shane has a double letter but doesn't end in a vowel, so she actually counts in this. So what we had noticed is that in terms of the total number of people that are doubled from before, plus the one extra here now, is how many? Okay, and again, we saw this before. So in terms of a repeated letter, a double letter, there were 2, but now there's 3. Does that make sense? In particular, there's actually, no, there's more than 3. Did we get another person? I'm just looking. We got Savannah, Pooja, Brittany, myself, and Shane. So that is 5, right? And then there were 2 that end in a vowel, Kate and Pooja. But then we got to subtract off Pooja because she was counted twice. Is that clear? So what we do here, and let me write down a little formula for you. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So that's an important formula. So in particular, and again, we got to change things a little bit because Shane came in, and so we got one more person. So the probability of A, that was, how many did we say? Double letters. That was 1, 2, 3, 4, 5. Okay, so that's 5 over 11. And then plus the probability of B, and that was the Kate and Pooja. That was 2 over 11. But then minus the 1 over 11. Any questions on that? Okay, and that's 6 over 11. Any questions on that idea right there? So again, my big warning is it's much easier to watch me do probability problems than do them yourself. So trust me, it's going to be challenging for you when you're asked these kind of probability questions. And again, not right now, but when you start having to do it yourself, it's a lot harder. Any questions so far? All right, let's do another one. If a person with a double letter is selected at random, what is the probability that the person will have a vowel at the end? Any questions on the question? Okay, so this is a little different. Okay, it's actually a lot different because now we're told something about the person before we're asked the question about the probability. So the way we write this is we write P, parentheses, then you're going to have our question is what's the probability that they're going to have a vowel at the end, and a vowel at the end was B, and then given A. Sorry, vowel at the end was A, not B. Got it backwards. I had to go back and look what I call them. The vowel at the end was A. So what is the probability of the vowel at the end, which is A, given, yeah, I am typing as we go, but I have to hit enter, given B. So first, that's how you write it. I always say it first because remember, the recording doesn't show the chat. So I have to say it first and then you'll see it. So it's P, parenthesis A, and then a little vertical line segment, and then B, and the parenthesis. That's how you write a given statement when you know something about the population, and now you want to find out about a probability. So let me give you a formula on this. There's the two ways of doing it, but I want to give you the formal formula first. First, that is equal to the probability of A and B divided by the probability of B. Any questions on the formula? Okay, so in particular, the probability of A and B that was just Pooja, remember, who is both the and, that's going to be 1 over 11 is the probability of A and B divided by the probability of B. Okay, and the probability of B is the probability of a double letter, and that was 5 over 11. Any questions on this so far? All right, now what we do is we can divide those fractions. Shane does not have her vowel at the end because it's Shane Bilgar. And there's an R at the end of her last name. So I'm looking at the full name, not the just piece of the name. And it's R. Does that make sense, Brittany? That's why it's a 1 out of 11. Okay, by the way, just out there, but it's kind of important to understand this kind of thing. How do you think I made money on this? Any thoughts? Personally, pretty much money, thousands of dollars. And you might know if you happen to have read my Sunday post on the 2 truths, 1 untruth. Any thoughts? I don't see you typing in all at once. Making predictions, but in particular, card counting. Card counting. So the idea of what card counting is all about is you're trying to have knowledge about an event that already occurred, and that is what cards you've already seen, and then calculate the new probability of winning or losing and making your bet based on that. Does that make sense? Okay. Yeah, so that's what card counting is all about. And then you got to be real careful because they told me they were going to kill me if I ever came back. So I never came back. Okay. I was more than kicked out. It was much worse than kicked out. Yeah. The second time I went to a different casino, but I was already on their hit list for the entire city of Las Vegas. So because I was a card counter, because they know that I'm going to make money. And in those days, it was all mafia driven, and that's how they dealt with things. They just killed people. But fortunately, I was not that stupid, and I'm still around. Okay, so that was a true story, and I did make thousands of dollars. Yeah, I wasn't a gangsta. Someone else was a gangsta. I was just a card counter. I was a math guy. Okay, but I also make money on this in the stock market. What I do, okay, and that's more recent, and nobody's going to kill you for this one. Okay, what I do is I look at what has happened in the past. I look at what just happened, and then based on that, I compute new probabilities and find out what stocks have the highest probability or what time a specific stock has the highest probability of going up. Okay, and I've made thousands of dollars doing that also. So just let you know that, you know, there's money to be made in this stuff. And the card counting doesn't work as well anymore. That's a longer story. I'm not going to get into that. But the stock market does happen. And if you're very good at it and really focus, you can actually make a lot of money on card count on the stock market. Okay, or you could just throw your money in an index fund and still make decent money, but not quite as much. So any questions on kind of the idea of this probability stuff? Okay, the next thing, I want to give you an example. And this one, I think I'm going to share my desktop so we can do a Zoom thing, and then we'll do a calculator thing. Actually, I don't. It's not even Zoom that I'm going to do. Sorry about that. Can't hurt to have Zoom though. So what I'm going to do is I'm going to show you something. I went and bought something today. And by the way, this wasn't because it was smart money-wise. This was so I can bring it in today into the webinar. Do you recognize this? Yeah. If Pooja, you don't recognize it, let me tell you what it is. This is a lottery ticket. Okay, which, by the way, I get to find out on Wednesday. And if I win, let's find out. So I'm going to share my desktop again, but I'm going to share it differently. I didn't want to do paint yet. We'll do that in a little bit. So let me do a new share and let us go. I think it's this one, and then we'll get to it. And here we are. And in fact, if you look at it, this is the Powerball. So the next big jackpot is $296 million. So, by the way, if I win, okay, especially if I'm the only winner, then I promise I will donate money to the college to start a dormitory here. Okay, it probably costs $5 million, but hey, I'll have it. Sound good? Because I think that's what the college needs. So should I go talk to our foundation office and make appointments now? What do you think? Okay, we got a yes, we got a negative. All right, so the bigger question is, what is the probability that this is a winning ticket? Got it? So what's the probability we have a winning ticket right here? And you have to look really closely. Notice I picked 3 sets of numbers. Okay, it cost me a little more money, but I wanted to do it. Okay, basically so I can explain something in class today. So what is the probability that this is a winning ticket? Well, we need a few things. One is we need to understand how the Powerball lottery works. So let me scroll down a bit on the how to play. Step one, and that's really what we need to know, is we need to go to any lottery retailer. Ashley went to 7-Eleven because that's the closest one that sold lottery tickets from my office. It was about a 15-minute, more like a 20-minute walk, and it was beautiful. Then we're going to pick 5 numbers. Let me write this down on my paper, between 1 and 69. And then we're going to pick 1 number between 1 and 26. Okay. And then what's going to happen? Is on Wednesday, they're going to pick 5 numbers out of one tub and 1 number out of another tub. And there could be a repeat of the 2 tubs, but the 5 numbers out of one tub, they pick the number and then they put it somewhere else and they pick another number. So for this one tub, you're not going to get the same number twice. Is that clear? And that's really important. So for the tub that they're not picking the same number twice, we call that without replacement. Without replacement means that you're going to pick the number, look at it, throw it out, and then pick another number. Okay? On the other hand, if I tell you roll a die twice, I got a 5. Could I get another 5 for the next roll? Yeah, that's called with replacement, okay, because I'm allowing the 5 to be picked again. Do you see that? And that's actually really important, this without and with replacement idea. So now let's go ahead and find out the probability that I have a winning ticket. Again, here it is. Okay. So let's go ahead and let me do a new share. And now I need to type some stuff out. So we want the probability of a win. Any questions so far? Okay, now that I got that, what I got to do is remember that probabilities are fractions. Probabilities are fractions. The numerator is how many different combinations make me win. And that's supposed to be very easy. Look carefully. How many different combinations make me win? And you got to remember what I said, or you had to look at the lottery ticket again. Not 5, 3. There's 3 groups of numbers. I bought 3 tickets, basically. So the numerator is a 3. All right, now the denominator is much harder. Okay, that 3, hopefully, I know not everyone said 3, but that 3 was supposed to be easy because I just bought 3 tickets, right? All on the same ticket is the way it works. Okay, so now the denominator are all the different possibilities that could happen. And what we're doing is first we're picking 5 numbers from 1 to 69. The way we write that mathematically in symbols are the following. We write down 69 C5. So what that means is we're choosing 5 numbers out of 69 without replacement. Okay, there's a math formula for that. I don't need to get into it because we're going to use our calculator. Sound good? Okay, then there's also a number from 1 to 26. And I'm going to use the multiplication principle. And that says if you have 2 independent events, so if we know what happened for the first 5 numbers, it tells us nothing about that last number. Yeah, C stands for the word choose. Exactly, Pooja. Okay. Also stands for the word combinations, depending on who you talk to. So sometimes you call it combinations, sometimes you call it choose, and they both work. So then what we're going to do is we're going to use the multiplication principle, which says that since they're independent, we can multiply. This only works when they're independent. So we're going to multiply by, well, there's 26 possible last numbers that I got to choose from. So I'm going to multiply by 26. Any questions on that? So let me write that down. 3 over 69 C5 times 26. So now what I'm going to do is I'm going to show you how to do this in a calculator. 26 came from, maybe I'll share and you can see. So in the rules, this is lottery. You pick one number between 1 and 26. Does that make sense, Kate? Or Pooja actually asked. Is that clear? Yeah. So that came again. That's how the lottery works. I didn't do it. Okay, that's something the state does. Okay, but I did vote for it. Some of you weren't even born when we started with the lottery. I was 18. It was my first election. Okay, so now let's reshare. And now what I'm going to do is I'm going to share my calculator. It took a lot of work to get this calculator working. I had to get the college to work it out. So here it is. So what I'm going to do now is let's just find the denominator first. I want to show you how huge this thing is. So now follow along, and if you have your calculator, I always recommend following along. And yours might look slightly different. I'm going to go to the math button. Not yet, sorry. Let me go quit. First, I'm going to type in 69. Then I'm going to hit the math button. Then I'm going to scroll, then I'm going to scroll to the right till I get to prob, because we're in probability, right? Then I'm going to go to NCR and hit enter. And then you'll see that 69C, and now I want to pick 5 numbers, so I hit the number 5. Then I hit the right arrow to get out of that and hit times, and now I want to go 26. Enter. Okay, is this a big number? You know how to read this number? Okay, some of you don't even know how to read the number. It's such a big number. Let me read it to you. This says 292,201,338. Okay, that's the denominator. Let me write that down. I have some of it memorized, but not all of it. 292,201,338 is the denominator. Any questions on that? So in particular, my probability of winning is going to be 3 divided by that number. Actually, I didn't need to write that because here it is. So 292,201,338. And I divide. Okay, now I want to make sure, because the first time we've seen one of these, is we need to be able to read our calculator. Is the probability 1.026689, for example? Is that close to the probability? What do you think? Definitely not. What am I missing? Yeah, I'm missing the E negative 8, and that's really, really important in this class. You're going to see this happen a lot. What does E negative 8 mean on the calculator? Some of you might know, and if you don't, that's okay.
Scientific notation, you got to move the decimal point.
Yeah, exactly. That scientific notation, it means move the decimal place over 8 places to the left. So the first place moves it to the other side of the 1. And then we have 7 more, and you'll get 7 zeros. So you get 0.0000001026666, etc. Any questions on that idea? Which, by the way, is about 1 in 100 million chances for me to win this lottery. All right. So what do you think? Should I go make appointments to talk about my donating to get dorms? You think yes? I don't think so. Or how about this one? This sucker is worth, if it's a winner, around $296 million. So should you come find me in my office with a gun and steal this from me so you can get that big money? Okay. Unfortunately, you can't count cards, count anything for the lottery. Total luck. I only buy it so I can bring it up in class because it's a really good example of probability. And it talks about the multiplication principle. It talks about combinations. And it talks about how many ways of making it happen divided by all the total number of ways. And realizing you can't count them all. So in the first examples, we just counted how many people had, were total on the list, and there were 11. Well, good luck counting up to over 200 million, 290 something million. It's just not going to happen. You got to use math. I think I should only do one example of each type because I have another type and we want to talk about the project, Lucia. Okay, but there is an example on the long video. Okay, so watch one of those. Again, I can only do so many examples. I try not to make this, over an hour and a half for the video and for the webinar. Okay, and I will let you know that there are different kind of lottery tickets. So in the past, when I taught this class, I bought this one, Super Lotto. Okay, and that has different probability. I've also bought this one, Mega Millions. Any guess? Do you think I've won before? What do you think? Definitely not. Okay, there'd be dorms, right? Yeah, no, I have not won. I have won the little like $4, but I pay $6 and I win $4, so no, that's not really winning. Okay, but again, it's important to understand probability. All right, ready for some more probability questions? So let me share my desktop with a different share. Go back to Paint. And let's get rid of this. Select. Drop it. And let's put a new problem in. Let me get there. Okay, and I want to let you know in an hour, a little more than an hour, and actually not even a full hour because we also have to do the project. I can only do so much. I can't do every possible example. But let me do what's called a contingency table example. And let's see how it does in terms of the copying, pasting. I think it worked well. Ignore the number 1. That is just something from the Word document. All right, so let's look at another example. All right, the contingency table below gives the results of a survey from Tahoe residents asking them what market they shop at and what kind of car they drive. By the way, if you're from Tahoe, you know this was an old survey, or I made this up a long time ago because we now have a 4th grocery. But pretend we only have 3. Okay. A survey participant is randomly selected. So notice that you could be an economy car owner, an SUV, a sporty, or a none. You could have a Safeway, you could shop at Rayleigh's or Grocery Outlet. Any questions on looking at this? Okay, first I want to note what these numbers mean. So for example, this number 55, that means that there were 55 people who responded that they have an SUV and shop at Rayleigh's. Is that clear? Okay, so that's the first thing is how do you read a table like this? And that's how you read a table like this. The numbers tell you what, the both things that happen, row and column. All right, so now let's do some probabilities. So find the probability. I'm gonna make it a little smaller because I need space. Make that look smaller. The probability that the person shops at Raley's. Okay, so what do we have to do here? And the idea is we count. Okay, yeah, add the Raley shoppers. So let's do that, and we'll do it in red. In fact, we might need to add all the totals. So the Raleys, let's start there. 20. Let's add it up. 3 and 5 is 8, and 7 is 15, and 7 is 22. Carry the 2, 4, 9, 10, 102. Got it? Let's just do it in my head. You can use a calculator if you want. Let's do Safeway shoppers. So for Safeway shoppers, I'm doing this fast, so if I made a mistake, I apologize. Okay, so 5 and 2 is 7, and 2 is 9, and 9 is 18. So we got 8. And then carry the 1, 4, 10, 11, 118. And then we have the grocery outlet shoppers. The grocery outlet is 8 and 4 is 12, and 1 is 13, and 6 is 19. 9, carry the 1, 1 and 4 is 5, and 3 more is 8. So 89. Any questions on just calculating it out? Okay. Any questions? Add up all the people who shop. Yeah. Okay, so now let's add this. So we need the full number of people. So let's do 118 plus 102 plus 89. Notice that 118 plus 102, 220, plus 89 is 309. If I did my head right. So let me just put that over here for total. Okay, any questions on that? So now we're ready. Probability that the person shops at Raley's is going to be the number. So I'm going to write this first thing. It's always good to write in symbols. Probability of R is equal to the number in R, which is 102, divided by the total, which is 309. Any questions on that? I'm not going to spend time putting in my calculator. I think you know how to do division. I hope so. Nothing too fancy there. Any questions at all on that probability? All right, let's do another one. If a person shops is found shopping at grocery outlet, I'll just write GO for grocery outlet. Find the probability that person drives an economy car. Any questions on this? Okay, so the idea here is now what we can do is this, what kind of problem is that? And that's always what you want to do in terms of symbols. It's similar to one that we did before. That was the probability of Yeah, the one with the vertical line. We call that a given. Call that a given. So it's going to be, I'm going to call it E for economy, given G for grocery outlet. And the easier, we could do the formula, but it's easier to do it a different way for this particular example, since we've already done our checking it out. So what we've done is we're saying we're only looking at grocery outlet. That's our new population. And there are 89 in that population. Do you see that? And there were 48 that shop at grocery outlet. So the answer is just 48 over 89. That turns out, for this example, when you have contingency tables, it's much easier to do it this way. So again, depending on the example is how you're going to do it. Okay, the next one is I want to give you a definition. A and B are mutually exclusive if the probability of A and B is equal to 0. Okay, in other words, they can't both happen at the same time. So, any questions on that? Okay, another definition. A and B are independent if either one, probability of A given B is equal to the probability of A. Another way of thinking about that is being told that you have B doesn't change the probability at all. So 2, the probability of B given A is equal to the probability of B. So being told that you're given A doesn't change the probability of B at all. And then 3 is the probability of A and B is equal to the probability of A times the probability of B. Okay, and it turns out if one of those is true, they're all true. If one is false, they're all false. Got it? For these independent three things. So let's ask a question. Are shopping at Safeway and owning an SUV mutually exclusive? Independent? Or neither? I should say both or neither. Any questions on the question? Okay, so let's first check for mutually exclusive. So then I got to check to see what the probability of A and B is. Let's do the work. Probability of A and B. What is that? I'm looking for numbers. That's Safeway and SUV. at 62 divided by 309. Any questions on how I got that? Now, is that equal to 0? I hope you don't need a calculator to tell me. Is that equal to 0? No. So it's not 0, so not mutually exclusive. I'm going to write ME for mutually exclusive. Any questions on that? Any questions? Okay, so now let's test to see if they're independent or not. We could choose any of them. What I find is that if you have a choice, usually 1 or 2 is easier than 3, because 1 and 2 only have 2 things, and 3 has 3 probabilities. Do you see? So in terms of easier. Yeah, so if it were equal, it means mutually exclusive, because that's the definition. Do you see that? It says definition, A and B mutually exclusive, if the probability of A and B equals 0. Does that make sense, David? That's right from the definition. So I'm going to test probability of A given B. Let's calculate that. So probability of A given B is equal to, well, now we're looking at, and in fact, let's see if that's the one I want to do. Actually, I think I'm going to test the probability of B given A, because it's easier to find those numbers. Maybe it doesn't matter, but I haven't tried that one yet. Okay, probability of B given A, that's the probability of owning an SUV knowing that they're at Safeway. Well, there are 62 SUV owners at Safeway out of 118. Any questions on that? Okay, now let's find the probability of B. So the probability of B is, that means the probability of owning an SUV. So we got to count that. So how many SUVers are there? Let's see, 2 and 5 is 7, and 4 is 11. Carry the 1. 6 and 5 is 11, plus carry 1 and 1 more is 13. So that's 1, 3, 1. Divided by 309. Okay, you're allowed a calculator, okay, because most of you probably don't love checking fractions to see if they're equal, but it's really easy if you just plug both of those in a calculator, see if you get the same answer. So let me ask you, I'm going to let you try. Look at these 2 fractions, put it in a calculator, tell me if you get the same answer. Are they the same or are they different? I could do it in my head, but I don't expect you to be able to do that. Yeah, they're definitely different. Let me tell you what I did in my head. 62 over 118 is more than a half, and 131 over 309 is less than a half. So they're different. So that tells you not independent. So the answer is neither. Any questions at all on any of these examples? Okay, there's a lot to talk about today, and there's a lot of different examples I can give you. So I went a little longer. It's going to go a little longer than usual because we have a lot today. Today's a busy day. The big warning is watching me do it is not the same thing as you doing it yourself. These can get hard. But there's lots of examples, I also have videos with examples, and you'll get to do homework. Where did the 131 come from? Okay, so I'm looking at, again, this is the probability of B. So those were the SUVers, 62 plus 55 plus 14. So I added those three numbers, and those three numbers were gave 131. Does that make sense, Savannah? Yeah, so that's an addition problem. But you get a calculator, by the way. I do it in my head just because it's faster. You please use a calculator. Okay, doing it in your head is a bad idea. And I make mistakes sometimes, I do it in my head. Okay, what I want to do now is the following. The secret word, and the secret word of the day is count. Because when we do probability, what we're doing is we're counting. Sometimes interesting ways of counting, but we're counting. So the secret word of the day, the secret word for this week is count. Got it? Okay, so now I'm gonna reshare, and we're gonna go to the course page. That one is, let me find it. There, that was our Powerball one. And here's our course. By the way, the new home page is the modules, because that's the most important one. Only the first week I made sure that it was the syllabus, but now we're at the modules. Okay. But I want to talk about the project, so let's go to the syllabus. So when you go to the syllabus, you will see Project 1. So I'm going to click on that and we'll talk about it. Okay, so these are the requirements for Project 1. And as I go through this, I'm also going to talk about kind of timelines and what to do. So what is the very first thing, because I've already told you to do it, and I said by now you're supposed to have already done it, that you're supposed to do for this project? Yeah, get partners. Okay, if you do not have partners, you should be worried at this point, because you don't want to be left out alone, because there is a, I think it's a 25% penalty for not having partners. It's really harsh. You pretty much can't pass, can't have a passing project without getting partners, because you would have to get over 95, you have to get at least 95%, which is really hard to do by yourself. Okay, people get over 95%, but it's almost always a good group of partners. Okay, and then you still get a C even if you got a 95%. Okay, a low C. So get partners. That's absolutely important. Should have already been done. Okay, if not, panic and post in the project discussion board. Also, note, if you only have 2 in your partnership, look at the project discussion board and please invite anyone up who is asking to be a partner. Got it? Okay. And sometimes I'll ask you to do that if you don't yourselves, but you should ask. So 3 is best. Any questions so far? Okay, this particular project is all about surveys. So we've actually had everything, first week of class had a lot of that, and that's most of what we're doing. So I went fast through the first week of class, but that doesn't mean it's over. So I only did that so we can move on, and we go back to the first week of class with this project. So the first week of that, chapter 1 and chapter 2, we actually spend more than 1 week on because I'm doing it again right now. So the first thing you have to do after you have project partners is you're going to think of a quantitative investigation that someone might contract out to have done. Do you guys remember what quantitative means? What that word quantitative means? Very important word. Not categories. Not quite. Yeah, it means that the answer to the survey question is a number. I like what Kate said. So what I recommend doing is write down the survey question and ask your partner and see what comes out of your partner's mouth. or typed if you're using that kind of thing. And if the person doesn't say a number like 23, then this is not going to work. If the person says yes or no to the survey question, it can't work. It has to be quantitative because we're going to be doing a lot of math in this. And quantitative numbers are good for math. All right. The next step, which doesn't say here, but I want to let you know, once you have decided on the quantitative investigation and see the someone, you should identify the someone. It can be fictitious. You don't actually have to call the someone. I mean, if the someone is, I don't know, the governor of California, you don't have to like call the governor. You can, but they probably want to answer. You probably want to answer Newsom. Instead, just identify who that theoretical someone would be. If nobody would be interested in hiring you out, then this isn't a good project. Doesn't mean you actually have to get hired, but you have to, in your paper, you're going to be saying who's hiring you. And your audience in the writing of the paper will be the someone who's hiring you. Got it? Next, what you do is you're going to go to discussions. You're going to go to Project 1 discussion forum. And you're going to go reply. And you are going to write down what your proposal is for your project. So you want to identify who your client is. You want to identify what your survey question is going to be. And you want to identify how are you going to select your respondents for the survey itself. And what I will do is I'll look at it and I'll let you know whether it's going to work or not. And if it doesn't work, I'll let you know how to adjust it or modify it to make it work. Okay, if you don't do this, then it usually goes very badly for you because you usually make mistakes. And if I don't help you fix mistakes, the project is awful. Okay, so you definitely want to do that. The other thing, as people post in the project discussion forum, you're going to be able to see what works and what doesn't work for other people so that you can avoid those mistakes or model after things that work. Okay, but don't pick one that's already been picked. So if somebody asks, I don't know, something like, let me do one that you probably wouldn't be as interested in. If someone asks something like, how much money do you have right now on you? And that's a quantitative study. You can't do your project on the same question. Does that make sense? You have to do your own. So Pooja said, when do you want the information by? So let me give you some more timeline. I like to work backwards. So let me go to syllabus again. If you go to syllabus, you will see the project 1 is due February 2nd. Okay, it seems like a long time from now, but today's the 13th. So February 2nd is another, what, almost 3 weeks. Okay, but this takes time. So I would say by Sunday probably is a good idea. Again, there's no specific deadline, but that's my recommendation, is have it decided on by Sunday. Okay. So the client's name or organization, if it's an organization, the survey question, and who you're going to ask. And I'll talk about who you're going to ask in a second. Those are the 3 things, Kate. Is that clear? Okay, so the next thing is you're going to have to decide who you're going to ask. And you have 2 choices. Okay, the choices are stratified sampling or cluster sampling. You must use one of those 2. And I have links. I'll let you click on these links to give you the step-by-step process that stratified sampling has and the step-by-step process that cluster sampling has. So when I say who you're going to ask, it better be either stratified sampling or cluster sampling. And you want to type in your in that project discussion board what your process is going to be to ask. okay? Your step-by-step process. And then I'll let you know if that's going to work or not. Okay, this has to be a survey of people, by the way. Okay, that is important. Any questions so far? Okay, so your next step after you get the okay that this is going to work is you do your survey. And you must survey more than 30 people. So by the way, if there are 3 of you, we're talking about 11 people each. That's not hard. Okay, it shouldn't take too long to survey 11 people. Any questions on that? Okay, now you can, you don't have to share it exactly even, but you can if you want to. Okay, once you've surveyed those people and write down the answers, which will be, say, maybe 35 numbers on a piece of paper. By the way, don't survey 300 people. It just takes a lot of time and a lot of work, and you won't have time to do a good project if you spend all your time asking people. So people usually survey between 31 and 50. Okay, that's my recommendation. Okay, 30 is not okay. 30 is not greater than 30. Just let you know that. Any questions on that? Okay, so once you have conducted your survey, and my recommendation is that you conduct your survey at least a week before the project is due. So again, the project is due February 3rd, and a week before February 3rd is January, I'm looking at a calendar right now, January 26th. So you definitely want to have your survey done by January 26th. Okay. Once you have your survey completed, so you're going to have these numbers written on pieces of paper or a piece of paper, your next step is to go to the spreadsheet. And you type in the numbers. You'll type them in here. And by the way, you're not doing a comparison study. You should only have one column of numbers. If you have more than one column numbers, you're not doing it right. Just one column of numbers, period. Got it? One survey question that might say, how much money do you have in your pocket right now? Okay. Okay. If you're doing stratified sampling, you might ask about, say, their ethnicity, but that doesn't go in your project spreadsheet at all. That it goes in the write-up, but not the spreadsheet. You're not comparing the ethnicities. You would be using them to make sure you have at least not something biased by ethnicity. Any questions on this? Okay, when you put in all your numbers, some important stuff is going to happen. One, the minimum, the mean, the variance. Okay, variance is not that important, actually. I shouldn't have said that. Minimum, the mean, the sample standard deviation, the median, the max, the third quartile, the sample size, and the first quartile. Those are your important statistics. Any questions on that? Okay, you're going to do a lot of stuff with the statistics. One is look at all these things. The other is check for outliers. Remember, you check for outliers, you could put in your value of X, the minimum and the max, for example, to see if they're outliers. Once you put that in, if you get a z-score less than -3, you have an outlier on the low side. If you get an extreme outlier, if a z-score is less than -2, you get an outlier. If it's greater than 2, it's an outlier. And if it's greater than -3, if it's greater than 3, you get an extreme outlier. That happened earlier. Okay. You also look at the histogram. And remember, the histogram helps you understand what the distribution looks like. Is it normal? Is it uniform? Is it something different? What's the shape of the distribution? You also must look at stem and leaf plot. And that was, remember, if you go to stats, you go to stem and leaf. And there's a stem and leaf. You should also look at a box plot. And you're going to go to box plot. And there's the box plot. Okay. If your computer's stopping you from doing this, there's some security issues, and I promise I have not put any viruses on this to destroy your computer, but some computers are like paranoid. Then I do have some other links to get the stem and leaf and the box plot. Okay, but I've programmed, so it just happens all in the spreadsheet. Any questions on this so far? Okay, just a note, in your project, here's something you need to do. You need to do a screenshot of the important piece of the spreadsheet. So what you can do is you can use, say, snipping tools. Have you guys heard of snipping tools? Yeah, that's something that's on every Windows computer. Mac has something similar. I'm not a Mac user, but if you any Mac users that know of it, you can say what the name is. I don't really know. But Mac has something similar. You go to snipping tools. Once you go to snipping tools, you can highlight the important piece, which is C and D. Do you see that? And then copy and paste into your paper. Got it? Okay, so the spreadsheet must be included in your paper or I take off 10%. So I think I mentioned in the orientation, my number one thing that I make sure of when I design the course is that this course transfers. And there are some universities that don't accept a statistics course for transfer unless spreadsheets are required. And this is a way we've proven that you're using a spreadsheet for this class. Got it? Because my guess is most of you would drop the class if you found out this doesn't transfer. Okay, maybe not, but my guess so. C&D is enough, yeah. You don't need to do the help links and the data itself. You don't have to show me all the data, but I need to see the statistics in a spreadsheet. One thing is it proves that you've used a spreadsheet because it's in your paper, and the other is it's got all the stats, so I can actually make sure that you are citing the right things. Okay, and you could put the spreadsheet in your bibliography if you want. Okay, it's a good idea. You should always cite your source. Any questions so far? Okay, let me go back to the project. I want to talk about a lot of things. Okay, so let me read through this, and this is really important. This is what a lot of people miss out on. So the purpose of the report is to make recommendations based on your findings. So you're not just saying the standard deviation was 3.7. Okay, that doesn't say anything. Instead, you need to say, what are your recommendations to your client for decisions that the client needs to make based on that number? Okay, it might be how the client's going to advertise, or it might be, you know, what kind of policy the client is going to make based on it. Okay, for every single one of the statistics and every single chart. Got it? Any questions on this so far? Okay, make sure you describe the sampling technique. Talk about the bias. Okay, if you think that there's no bias in your project, you better have a really convincing argument, because I'm not going to believe you. Okay, I do not grade off because you have bias. I grade off because you haven't identified the bias. Is that clear? So if you say, here's another word to avoid. If you think you use random sampling, think again. Okay, it's like almost impossible to do that. So the only way you would use the word random is saying this was not a random sample. Basically saying you didn't do it. Okay, so avoid saying you randomly sampled, because you're not going to be able to do that. Got it? Okay, it's just not, it's like almost impossible. So good luck. A couple more legal things. If you're surveying college students, you can survey any student. If you're surveying non-college students, you're not allowed to survey people under 18. You guys know why? I think I mentioned it. I'm not sure if I mentioned it or not, but anyone know why? Yeah, legal reasons. I don't want to get sued, and you don't want to get sued. Got it? Yeah. So just don't even do it. If it's a college student, then they have given up their rights, or their parents have given up their rights, and you're allowed to survey them. Okay? Any questions on that? Okay, something that I don't know if it's mentioned here, but you should do is note who your population is. So it could be all college students. It could be all students at your college. It could be all people in California. Okay, there's lots of different possible populations. Could be everyone who, everybody who is a customer at your business, depending on what your survey is all about. Does that make sense? But you should identify it. Who is your population? Who are your population? All right. I already mentioned that you have to include all the charts and the statistics. I want to mention a few things. You should interpret everything. Compare and contrast is a good idea. You should talk about all the summary statistics, and the standard deviation is really important. Okay, the standard deviation is the key statistic. So that's one you got to really understand. Talk about how the client is going to use the standard deviation, use that information. Talk about the z-score, okay, and why you used X, okay, and maybe a few different z-scores. Okay, talk about the empirical rule or Chebyshev's theorem. If you can use the empirical rule, you don't need to use Chebyshev's theorem. If you can't use the empirical rule, Chebyshev's theorem is like last resort. Worse information, but you can't use Chebyshev. I mean, you can't use empirical rule. How are you going to know if you can use empirical rule? What piece of information from the spreadsheet? Anyone know? Yeah, and how from the spreadsheet you can know if it's normal? So you're right, Pooja, you can check if it's normal, but how are you going to look at the spreadsheet and know? Any thoughts? Not sure? Yeah, the graph, and in particular, which graph? There's 3 graphs you must include. Yeah, the histogram. The histogram will show you the shape. Stem and leaf also, by the way, but not the box plot. The box plot will not tell you if it's normal or not. The box plot will tell you about the middle 50% really well. So make sure you focus on that when you're talking about the box plot. Any questions on that? Okay. Note, make sure that you interpret the statistics in the context of the survey and how you're going to use them. And don't just give a definition. In fact, you don't need to write mathematical formulas for anything. Okay? Just assume that your client understands the math. Got it? So don't go into the equation for the standard deviation. It's not important. Okay, as soon as you say standard deviation, assume your client gets it. Okay, you should give me recommendations, 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 okay? I can't say that too many times. That's the #1 suggestion I make on people's papers, is they don't have enough recommendations, okay? All over the place. So, for example, if the study was done on the age students first learned the quadratic formula, and the mean was 15.3, don't just say the mean could be used to understand when people use the quadratic formula. Okay, that's not a recommendation. Instead, you'd write, students are learning the quadratic formula on average just after they turn 15. Based on this, high schools should be leery about moving chemistry, which requires this knowledge, to the freshman year. So that would be if, say, your client was the principal of a high school. Do you see that? So that's a recommendation to the principal. Okay. Also, you should always talk about how you could do further studies. And the further studies could relate to two different things. One is controlling some of the bias that you've identified. And the other is maybe expanding on the survey, asking more varied questions, for example, depending on what your project is. Any questions on that so far? Okay, a couple things. Notice this. I, me, we, and us should not be in the paper. This is not a paper about you. This is a paper about the statistics and about the recommendations. So those words should not even be in the paper at all. Got it? Okay, a lot of people put them in. They don't read this, and that's the way it is. All right, so a couple more things. Let me go back. I told you this is a little longer than usual, but I'm going to try and end before 7:30. We got 8 more minutes and I'm there. Okay, then I've ended on my goal. Okay, so under here, and this is very important, I will be happy to look at a rough draft of your paper, but you need to bring it to me by Thursday. Okay, and bring it means email it to me, really. Email it by Thursday at 8 a.m. before it's due. So that would be Thursday, let me get the calendar, January 30th. Okay, but if you wait till 7 a.m. on January 30th, then it might be a while before I get back to you, because this is a pretty big class, and each paper tends to be around 8 or 9 pages. Sometimes they're 8 pages, sometimes they're 25 pages. You don't need to write a 25-page paper, but some people do. Okay? 10 is a good number, 8, 9. If you think you can do it in 1 page, you're absolutely wrong. This is not a 1-page paper. But remember, if you do a 9-page paper, and there's 3 of you, I hope you can do the math, how many pages each? 3. That's not too bad, is it? Yeah, so that's one reason why I encourage partnerships. So again, if you each write 3 pages and then read each other's pages, make sure you agree with them and adjust them, edit it, that kind of thing, then you have a nice 9-page paper. And that's not so bad. So again, having a group makes it easier. Share the work. So again, if you send it to me like Tuesday or Wednesday morning, then I'll get it back to you really fast. Okay? If you wait till the last minute, it might take me a while, because reading through, say 13 papers, and they're each 10 pages each, that's 130 pages of work that I have to read through and write comments on. And I can't do that in an hour. Is that okay? So what I do is I do it on a first come, first serve basis. So there's a list from the emails, and I just go, the one that sent it first is the one I first read. Okay, and the one that sent it last is the one I last read. And if it's sent after 8 a.m. on Thursday, I don't read it. Okay, you only need to, so let me go more on this, just a minute. If you go to the week where you do the paper, and that is, I think that's week 5. Let's see if that's right. Might be week 4. Let me check. There it is. You go to week 4, project 1. There it is. Then what you do is you post, this is mine, so I can't post it, but you post your paper. Okay, a poster means send it via the assignment. Only one of the group needs to send the assignment. Okay, you get the same grade for all of you. But make sure that when you do submit the assignment, if you're the one submitting it, make sure that all of your names are on it so I can give points for everyone. Okay. So that is hopefully enough in terms of that. And then, by the way, after you submit your rough draft, I've given you comments. Then if you have questions, you ask questions via the Project One discussion board. Which is here. And then ask questions. That way other people can read the kind of questions people are asking, and then I can answer it and everyone benefits from the information. Okay, although you're all doing different projects, the goals are pretty much all the same and the outline is similar. So are there questions at all? And it's a paper, by the way, so you should have an introduction, a body, and a conclusion, just like any paper. Okay, and you should cite any references that you've got. Okay, I'm not picky about how you cite them. You should just cite them. If you give a link with the name of it, that's good enough for me. So it's 7:26. I made it by 7:30. That was my goal. I wanted to make sure that. And I've started grading, by the way, from your discussion posts that were due Sunday. And it usually takes a couple days and I'll have it done. But make sure you read my comments if there's comments. The main thing is, it has to be done by Thursday, and read the instructions. Some of you didn't reply. Some of you didn't tell everybody what your truths were and what was your not truth. So we don't even know. So always read the instructions and make sure you follow the instructions of discussion posts. Okay, so I will open this up. I think I'm going to unshare so we can see each other. And I'll open this up to any questions you might have. And as always, if you don't have questions, you can say goodnight. If you do have questions, I'll be happy to answer any question you might have. Could be about the project, it could be about chapter 3, could be whatever. But this is a good time, and you can talk it, you can say it, you can type in the chat box, whatever. Okay, good night, Brittany. And good night, Jeremy.
Hey, so I guess I'm a little slow or whatever, and I did it in the homework, but I just wanted to re-ask. When it says like the P and the parenthesis A and the vertical line B and parenthesis, that vertical line, the other word for given, would that be?
Okay, I just put in the chat box, so that's what you meant, right? I can't hear you anymore. Let me unmute you.
I'm on the phone, so it takes me a second to switch back and forth. I'll go look right now, see what.
Oh, okay. Yeah, so P, parenthesis A, vertical line segment B, and parenthesis. That's what I typed. That's probability of A given B, is how you read that.
Right.
And there's a couple formulas for that. I can't give you everything in the webinar because we went almost to 7:30, and I wanted to make sure I had time for the project, by the way. One was the probability of A and B divided by the probability of B. Another is the probability of, another is the total number of A and B divided by the total number in B. And I gave you an example of both today. Does it help, David?
Yeah, somewhat. I guess the main question, or maybe you're answering it, I'm just not quite understanding. I was just trying, like, is the word for the given also like saying divide? Like, as you would say, A plus B would be like A and B. Would that line mean divide or given?
It's not a divide, it's just given. The way you read it is probability of A given B. Got it?
Yeah, that makes a little more sense. That way I don't always think divide.
Yeah, and notice that all probabilities have a divide, right? Because always the total number of ways of having it happen versus the total number of things that can happen. Does that make sense?
Yeah, it makes more sense now. Thank you.
So whether you're using and, or, given, or just a probability, there's always a division sign. So that vertical line is just to say there's two sides. There's what you want and what you know. And the left is what you want, the right is what you know.
Now, that way of working made it clear. That helps a lot.
Oh, good, good. I'm glad it's clear.
Have a good night, sir. I'm out.
Yeah. We lost you. You're on mute.
Oh, I was just saying, have a good night, sir.
Oh, yeah, you too. Have a good night, David. And Pooja and Kate and Shane, I don't know how to pronounce your name, sorry. Any questions? I just call you Ms. Belgar. Any questions? Kate? If there's no questions, I'll say good night. And for all of you watching this as an archived video, don't forget that it's really important that you have a partner and that you and your partner decide on what interests you for a good survey. And I didn't mention this, but you want to have lots of different possible numbers. You don't want to do something that only has like 1 or 2 numbers possible. So scale of 1 to 100 is better than a scale of 1 to 10, for example. But other than that, hope you have a great week, and I'll be checking all the forums, all the boards, to answer any questions you might have. So have a good night.